Hey, this is the second video for section 4.1. Part 4, Inconsistent and Redundant Systems. So example 5, solve the system x minus 2y equals 8 and 3x minus 6y equals 24. Since both of these equations are already in standard form, I'm going to choose to solve this by elimination. And what I'm going to do is just multiply the first equation by negative 3. Then this system becomes negative 3x plus 6y equals 8. 3x minus 6y. Oh, sorry, I made a mistake. The first equation should have equaled negative 24 and then equals 24. Now when I add these together, you'll notice everything cancels out. And we get 0 equals 0. So when you get a number is equal to itself, it doesn't necessarily have to be 0 and 0. It could be 3 equals 3 or negative 7 equals negative 7. Whenever you get a number equal to itself, that's telling you that there's infinitely many solutions. We call this redundant. We also call it a tautology. And we also call this a dependent system. So all of these terminologies mean the same thing. But these aren't the answer because there's infinitely many solutions. You have to tell me which solutions are what. So normally what you do is you take one of the equations. So I'm just going to take the first equation and then solve for x or y. In this case, I'm going to solve for x. We get x equal 2y plus 8. So that means when I write my solution, I know my x coordinate has to equal 2y plus 8. And what does that mean my y coordinate is? Well, whenever you have infinitely many solutions, one of your variables is what's called a free variable. In this case, since I solved for x, y is my free variable, so we'll just put y there. Now, there are some people that say you shouldn't use the same variables that you started out with, so sometimes people will use a entirely different variable here, like t, 2t plus 8, comma t. But I generally just use the same variables because there's not much confusion. Example 6. Solve the system 3x minus y equals 7 and 6x minus 2y equals 10. Again, they're both in standard form, so I'm going to use elimination. I'm going to multiply the first equation by negative 2. So we get negative 6x plus 2y equals negative 14. 6x minus 2y equals 10. And then we add these together. Oh, both our variables cancel out again, so we get 0. But on the other hand side of the equation, we get negative 4. So whenever you end up with a number equal to a different number, that means there is no solution. And this is what we call inconsistent. But it can also be called a contradiction. And since there is no solution, there isn't anything to write. Sometimes people do use the empty set symbol, which is a 0 with a line through it. So that's how you deal with redundant and inconsistent systems. And this is just going to go through the same terminology I just said. So we say a system like that in example 5 is redundant. When the solution set is infinite, graphically this means that we have the same line. Algebraically, we can see this by getting a tautology, like 0 equals 0, when we try to solve by resubstitution. Putting both lines in slope-intercept form, they will match exactly, or noticing that one equation is an exact scalar multiple of the other. We say a system like that in example 6 is inconsistent when there is no solution at all. Graphically, this means that we have parallel lines. Algebraically, we can see this by getting a contradiction like 0 equals 4 when we try to solve by resubstitution. Putting both lines in slope-intercept form, they will match slope but not intercept, or noticing that one equation is a scalar multiple of the other except for the constant term. Example 7. Without solving, determine the number of solutions of a system. So whenever the question asks you to do it without solving, the easiest way is to get both equations in slope-intercept form. So the first equation is already in slope-intercept form. It's y equals 3x minus 1. The second equation, we just got a little bit of work to do. So we get 6x minus 2y equals 12. To get in slope-intercept form, I'm going to subtract 6x. Get negative 2y equals negative 6x plus 12. Divide by negative 2. Divide by negative 2. Get y equals 3x minus 6. So now that they're both in slope-intercept form, I notice that they have the same slope. And different y-intercepts. They have the same slope because the m is 3, but different y-intercepts because one of the b's is negative 1, the other b is negative 6. So that means these are parallel lines, so there are no solutions. There would be infinitely many solutions if both the slope and y-intercept were the same. And there would only be one solution if they had different slopes. Doesn't matter about the y-intercept if they have different slopes. Example 8. For each system of linear equations, decide whether it would be more convenient to solve it by substitution or elimination. Explain your answer, then solve. So, in my opinion, elimination is always easier if it's in standard form, and substitution will only be easier if one of the equations starts out already solved. So in part A, they're both in standard form, so I'm going to say elimination. I'm going to eliminate the x's. I'm going to multiply by negative 2 on the first equation. So then it becomes negative 4x minus 2y equals positive 2. And then we get 4x plus 3y equals 3. So then when I add these, the x's cancel out. Negative 2y plus 3y is 1y, and 2 plus 3 is 5. So I get y equals 5. Now I just need to plug that back into one of the original equations to get x. So we get 2x plus 5 equals negative 1. Subtract 5, subtract 5. 2x equals negative 6. Divide by 2, divide by 2. X equals negative 3. And then don't forget, after you solve for x and y, your final answer should be in order to pair. So negative 3, 5. Part B. Again, both equations are in standard form, so I'm going to try elimination. This time it's a little bit more tricky because I'm going to have to multiply both equations by something to get them to match up. I'm going to choose to eliminate the y this time. So I'm going to take the first equation times 2 and the second equation times 3. That way, both of the y's will be 6. Just one will be negative 6, the other will be positive 6. So then that becomes 8x minus 6y equals 18. 21x plus 6y equals negative 18. 8x plus 21x is 29x. The y's cancel out. And then 18 plus negative 18 is 0. Divide by 29, divide by 29. We get x is equal to 0. So I got my x coordinate. Now I plug it back into one of the original equations and solve for y. I'm going to plug it into the second equation this time. 7 times 0 plus 2 times y equals negative 6. That becomes 2y equals negative 6. Divide by 2, divide by 2. Get y equals negative 3. So then our final answer is 0, negative 3. Part C. Again, they're both in standard form, so I'm going to go ahead with elimination. I'm going to eliminate the y's this time, multiply the second equation by 2. So we get 3x plus 8y equals 40 for the first equation still. Second equation becomes 14x minus 8y equals negative 64. 3x plus 14x is 17x. The y's cancel out. 40 minus 64 is 24. And then divide by 17. And divide by 17. We get x equals negative 24/17. So as you notice, it is possible to get fractions as your answer. Now I'm going to plug this into the first equation and then solve for y. So we get 3 times negative 24/17 plus 8y equals 40. What does that come out to be? Negative 72/17 plus 8y equals 40. Add 72/17 to both sides. Get 8y is equal to 752/17. And then because I have a fraction, I'm not going to multiply or divide by 8. I'm going to multiply by 1/8 on both sides. And we get y equals 94/17. So our answer is negative 24/17, comma 94/17. And last but not least, part D. So now here, my first equation is not in standard form. My first equation is solved for y. So I personally would solve this one by substitution. By substituting the first equation into the second equation to get 5x plus 6 times 2/3 x minus 1 equals 12. Don't forget, because y is being multiplied by 6, you have to multiply both 2/3 x and negative 1 by 6, which is indicated by the parentheses. So this becomes 5x plus 4x minus 6 equals 12. Add 6 to both sides. Combine like terms. You get 9x equals 18. Divide by 9. Divide by 9. X equals 2. Plug this in to either equation. I'm going to choose the first one. So we get y equals 2/3 times 2 minus 1, which is 4/3 minus 1, which is 1/3. So then our answer is 2, comma 1/3. And that is it for section 4.1.